Hey everyone. So in today's video, I'll be showing you guys how to calculate the molar mass of a compound, and we'll be going over numerous examples to show this process. So firstly, what is molar mass? So molar mass is the mass of 1 mole of a substance, and it's measured in grams per mole. And you calculate it by adding up the atomic masses of all the atoms in the compound. So the steps are as follows. First, we have to write the chemical formula. Then we have to list how many atoms of each element are present. Then we can use the periodic table to find each element's atomic mass, and we can multiply and add everything up. So let's go over some examples. So let's say we have H2O. Let's write out what we have. So H, there's two H's, and H, according to the periodic table, has a mass of 1.01 grams per mole. So that times 2, and then there's one O, and according to the periodic table, it has a mass of 16.00 grams per mole. Now, and that's times 1, since there's only one. So this is going to be equal to 2.02 grams per mole. And the O is just going to stay 16.00 grams per mole. And now, when we add these two up, we get, I'll just write it out down here, 2.02 plus 16.00 is equal to 18.02 grams per mole. So as you can see, the molar mass of H2O is 18.02 grams per mole. Let's try another example. Let's do CO2, carbon dioxide, CO2. Now for this, there's only one carbon, so the C, and it has an atomic mass of 12.01 grams per mole. 12.01 grams per mole. There's one of it, so we multiply it by 1, and it's going to be equal to 12.01 grams per mole. Now there's two oxygens, and as we discussed earlier, oxygen has an atomic mass of 16 grams per mole. Times 2 is going to be equal to 32.00 grams per mole. When we add the two up, 12.01 grams per mole plus 32.00 grams per mole, we're left with 44.01 grams per mole. Now let's try one last example together, and then I'll give you guys a few problems to try on your own. So let's say we have CaOH2, calcium hydroxide, CaOH2. We approach this the same way, even though now there's parentheses or brackets. So calcium, there's one of it, and it has an atomic mass of 40.08. Times 1 is equal to 40.08 grams per mole. Now for the OH2, we simply have to break it apart. There's two oxygens and there's two hydrogens, and we know those. So O is equal to 16.00 grams per mole times 2, which is going to make it 32.00 grams per mole. And then hydrogen also has two. There's two hydrogens, and it has an atomic mass of 1.01 grams per mole. So that times 2 is going to be equal to 2.02 grams per mole. And now when we add these three up, 40.08 grams per mole plus 32.00 grams per mole plus 2.02 grams per mole, we're left with 74.10 grams per mole. So the atomic mass of calcium hydroxide is 74.10 grams per mole. Now I'll give you guys 3 problems to try on your own, and then we'll solve them together afterwards. But be sure to pause the video and try these on your own. Let's do NaCl. Let's do NH3. And let's do Al2. Al2. SO4 3. Now, feel free to pause the video and try these on your own, but when you come back, you'll see the answers are as follows. For NaCl, I'm going to do this quickly since we've already gone over the process. The answer will be 22.99 plus 35.45 grams per mole, and that answer will be 58.44 grams per mole. So as you can see, the atomic mass of the sodium was 22.99 and the atomic mass of the chlorine was 35.45. For NH3, I'll also do this quickly. The atomic mass of the nitrogen is 14.01. And the atomic mass of the hydrogen is 1.01 times 3. So that's going to be 3.03. Excuse me. And so our final atomic mass for NH3 is going to be 17.04 grams per mole. And then for the last one here, this one's a long one. Since we have 2 aluminums, the atomic mass of aluminum is 26.98. So we can I'll show it down here. 26.98 times 2. Make that a little nicer. 26.98 times 2. Plus, then we have our atomic mass for the sulfate is for the sulfur, is 32.07. 32.07 times 3. And then plus our atomic mass for the oxygen is 16.00 times 12, since there's 12 oxygens. And when we add all these up, we're left with, and be sure to add them correctly in your calculator, 342.17 grams per mole. So as a quick recap, to calculate the molar mass, all we have to do is list all the atoms in the compound, multiply by their atomic masses, add everything together, and make sure we use grams per mole as our unit. Your teachers will deduct marks if you don't show the units.